All right, so now we're going to look at finding the standard deviation of a population. So population versus sample. Population is everything. A sample is a part of a population. So what makes this one a population? If we look at the example, the table displays the number of points scored in a football team during each of their regular season games. So this is all of their games represented. It's not a sample of their games represented. So that's why this is a population versus a sample. So what are the mean and standard deviation for this data set? So now that we know how to find it, we're going to be able to run through this a little bit quicker. First thing we have to find is the mean. So if you take all the data and divide by 1, 2, 3, 4, 5, 6, divide by 12, I'll just tell you some of these numbers to speed it along since we went through step by step the last one. The mean is about 16.8. We are rounding those. Next is where we would draw out that chart, and we would want to subtract each number from the mean. Maybe we will draw this out. So I'm going to draw this out, but I'm going to pause the video, draw it out, and then kind of talk through it in a second here. Okay, so there is the table. I didn't want to take video time to fill all that in, but let me just remind you how it works. X is our data value, so here are 12 scores of football games. Then we just have the average, just so we have that right there. We already found that was 16.8. Then we subtract the data point minus the average. You're going to have some positives, some negatives, depending on if the score was above or below the average. And then what we do is we square all those numbers. Now, when we square, we're using parentheses. So all of these numbers squared will turn positive, and we get these values down here. All right, so step 3 is finding the variance. Now, one notation, because we are talking about a population instead of a sample size, you'll see statisticians use that symbol. Remember, variance is the variance squared is what we want, and then the standard deviation is the square root of the variance. So the variance is going to be the average of all of these. So what we'll do is we add all these together, and let's see what we get. So we get 646.08. So that's just adding all these squares together, and we want the average of that. Now, the one thing we have to remember from our intro video, because we're dealing with a population, we divide by the exact number of how many there are. There were 12. When we were finding the standard deviation of a sample, we divided by 1 less than that. All right, so when we do that, we get about 53.8. And so our last step, to find the standard deviation, we just square root that 53.8, and we're going to get a standard deviation of about 7.3. So our mean was 16.8, standard deviation was 7.3. So as soon as you have the mean and your standard deviation, you can think through that for a second. If you have your mean and you add one standard deviation and subtract a standard deviation in either direction, like on that bell curve, that gives us on the low end about 10 and in the high end about 25. That means that the team scored about between 10 and 25 points in about 68% of the games. So remember, one standard deviation away on either side is about 68% of the time that happens. All right, so our next question, the team played 2 postseason games, scoring 7 points in one and 14 points in the other. How do these games affect the overall mean and standard deviation of the number of points scored all season? So what that's basically asking us to do is add in those 2 scores. So when we found our mean, well, I guess we said it was 16.8. Had we done that by hand, we would just add in plus a 7, plus a 14. The new mean, we'll just share what it is. If we include those two new scores, then our mean goes down a little bit. It goes down to 15.9. So now there's an average of 15.9 points scored per game. And the standard deviation, which would be represented with that guy, our standard deviation, it remains about 7.3. So the standard deviation didn't change too much, but the mean did go down just a little bit. All right, I think we have one more question to look at. All right, what was the range of points that the team scored in 95% of their regular season games? So first, regular season. So where we added in the two values, we don't have to worry about that. So what we'll want to know is the mean and the standard deviation of the regular season. We found that in up above. We'll do a little bit of rounding. So the mean was about 17, and the standard deviation will leave that at 7.3. So just a reminder how this works. When you have a normal distribution, you go 1 standard deviation, 2 standard deviations away, 3 standard deviations away in either direction. Pretend, oops. Oh goodness, what am I doing? There we go. Okay, so if you're within 1 standard deviation of the mean, remember the mean is in the middle, that's from here to here. That's 68.2% of the data. If we include in 2 standard deviations away, that's that 95% of the data. So when they're asking us what range of points, what was the range of points that the team scored in 95% of the regular season, we just want to figure out 2 standard deviations away from the mean. So if our mean is 17, we're going to add 7.3, and then we're going to add another 7.3. That will get us to 2 standard deviations away. We're going to go in the other directions. We're going to subtract 7.3 once. We're going to subtract 7.3 twice to get 2 standard deviations on the left side. So if we do that in either direction, that goes from about 2 points on the low end up to 32 points. So that tells us that the team scored, we'll put this in a sentence. The team scored between 2 and 32 points. Oops, make sure we spell correctly. In 95% of the regular season games. There we go. Oh, all right. Done with this video.